Okay, so the first thing that you do is you draw the loops with the currents. So each area is going to have its own current in it, and this one was given, I think it was, we'll just label it as I2 right now. My teacher makes us do everything where we don't have any numbers until we're like actually done, and then we plug in the numbers that were given. So what you want to do is you want to go around all the loops. So if we go around loop number 1, we're going to hit, like I like to start from probably like over here and then go around and go in a clockwise direction. So I would do I1, and then that's times R4. Um, and then we're going to do, there's a negative right here and a positive right there on the voltage. You can tell because the smaller piece down here means it's negative. So we're going to hit the negative side of that. So we're going to have minus Vs and then plus R1 times I1. Now we're going to get to like a little bit of the tricky part when we hit the R3 and the R7. So we're going around in the clockwise direction again, and we're going to hit that R3, so it's going to be plus R3, and that's going to be times I1, and then you want to subtract away the other current. So you have this current going this direction, and then you have the other current going this direction. So there's two opposite directions working there. So they're going to be going different directions, and so one of them is going to be positive, the one that we're working with, and one of them is going to be not negative, the one that we're not working with. So we're going to do I1 minus I3, and then you're going to do the same thing with R7, but I wrote really big so it doesn't fit. So we're going to put it over here. So plus R7 times I1, the current that we're working with, minus the current that is connected that we're not working with. So it's going to be I2 in this case. So minus I2. And then we want to set everything equal to 0. So one way to remember how to actually do this is, because this is, I don't remember if it's like ohms or what it is. I think it's ohms. I don't know. Anyways, so there's like, we're doing all the voltages, and you know that V is equal to IR. So that's what we're doing right here, is we want to multiply the currents times the resistances, so that way the only thing that we're dealing with is voltages. So then you can go ahead and like sum that together, and then you're going to do the same thing on the next loop. So this was loop number 1. And then we're going to do loop number 2. I'll do that one like in purple or something. So for loop number 2, we're going to be going around the loop, and we're going to be hitting the R5, the R7, and the R6. So we can do loop 2, but we already know what the current going through loop 2 is. And one really good thing that my teacher says is to always pick all of your currents going in the clockwise direction. And so you can see that this one right here, whenever we go around in the clockwise direction, that we're actually going the opposite direction of it by choosing to go clockwise. Well, that's okay, because we'll just, whatever I2 is, so say I2 was equal to like 3, I don't know, I didn't look at your numbers, but so you would just set it equal to negative that value, because it's going in the opposite direction. And yeah, that's how you do that. So we're not going to deal with the numbers right now, but just be aware that you would just set that to negative, and it is a lot easier to just make them all go the same direction. My pen's not working on this stupid thing. So then for loop 2, trying to figure out why my pen's not working. Okay, so we're going to go around loop 2, and we're going to hit R5. That's going to be multiplied by I2. And then we're going to add that to R7. And we're going to multiply that by the current that we're working with, minus the current that we're not working with. So it's connected to I1 as well, but we're not working with I1 in this case, so we're just going to subtract it. And then we're doing plus R6 and then multiply that by the current that we're working with, which was I2, minus the one that it's touching that we're not working with, which is going to be I3 up here. So notice again that we have one current going this direction for the I3, and then the I2 is going the other direction. So whenever they're going opposite directions, they're going to be subtracting. So my pen stopped working again. Minus I3. And now you're going to set that equal to 0. Because that's like one of the rules is that you just set it equal to 0. So then on the last loop, we're going to be doing the same thing that we just did with all the other ones. So it's just going to be going around the loop and then multiplying all the resistors by the currents to get a voltage and then setting it equal to 0. So we're going to have R6 multiplied by I3, and then we're going to subtract away the other current that it's touching, so minus I2, and then plus R3 multiplied by the current that we're working with, which is I3, minus the current that it's touching that we're not working with, which is I1, and then plus R2 times I3, and in this case it's not touching any other current source, so we don't need to subtract anything, and then equal to 0. And now we just like simplify everything. So we're done with the drawing at this point, so I guess I'll just like scroll down if I can figure that out. So now we're gonna like simplify all of our stuff, so just draw a line, and then so one way that you can solve it as equations, so they've already provided us with the resistor values. I noticed that. So what we're actually solving for is each of the currents. So you're going to have like I1, I2, and I3. And you kind of want to set it up in a in like a matrix form. So just go ahead and like multiply everything out and just kind of like simplify. Like all these R's are going to multiply to these I's. So you're going to have I1 times R4 minus VS plus R1 times I1 plus R3 minus